If you're watching this video, hopefully you already have a basic understanding of what parametric equations are. If you haven't, then I would encourage you to look at the parametric equations intro video I have. But now we're going to look at the calculus that we are going to be doing with parametric equations. So one thing that's commonly used with parametric equations is position, velocity, and acceleration. Because one of the benefits of parametric equations is it allows you to look at both horizontal and vertical movement and how they change over time. That can be really important when you're talking about the physics of projectiles or even rockets or things involving wind, because you've got force pushing things left and right, as well as gravity pulling things down, or rockets propelling things upward, things like that. So it's helpful sometimes to separate the horizontal and the vertical movement and forces. So one thing they may ask you to do is just find the velocity equations. So we'll start with that first part, find the velocity equations. Well, if you remember, this is going to be the same as the basic position, velocity, acceleration. Position is your original function. Velocity is just your first derivative. So x prime would be cosine t, and y prime would be negative sine t. And that's it. Those are the velocity equations. Now the second part says find the acceleration vector at time 0. Okay, so first we're going to have to find the acceleration. That's the second derivative, so that's going to give me negative sine t and negative cosine t. And then we're going to have to plug in 0. So if we plug in 0 to sine, we get 0. Plug in 0 for cosine, we get 1, so that's negative 1. So this would be our acceleration vector. The AP test will also allow you to write it as an ordered pair, but a vector is more normally written with the little kind of carets on each side. So the velocity is just the first derivative of each one. The acceleration is the second derivative. And as for the vector at a point, you just need to plug that point into your two equations and write it as a vector. Okay, so another similar example. Given a position function, x equals the square root of t and y equals 1/4 times t squared minus 4, find the velocity vector. So remember, the previous one, it was the acceleration vector they wanted. This one is just the velocity. So we take the first derivative, and then plug in 2. So if we plug in 2 to x prime, we get 1 over 2 square root of 2. If we plug in 2 into y prime, we get 1. So this would be our velocity vector. Okay, one other thing they may ask, where's the slope of the equation? So we have x equals and y equals, and they tell us to find the slope at time 1. So you need to think carefully about what slope really is. Think back to 7th or 8th grade when you first learned about slope. Well, slope is a rate of change, but more specifically, slope, at least how you learned it back then, is rise over run. It's really the change in y over the change in x. Well, hopefully, as you know now by now in calculus, that derivatives are what measures change. So we need to find the derivatives. And then we need to put the change in y over the change in x. So the slope would be 8t minus 1 over 2t plus 3. Because it's rise over run. It's y minus y1, or y1 minus y2 over x1 minus x2. Or, you know what I mean. The slope formula is the y's on top, x is on the bottom. So same idea here. We'll put the derivative of y on top, the derivative of x on the bottom. So that would be the slope of the equation. Then they want to know it at time 1, so I plug in 1, and I get 7 over 5. So my slope at that point would be 7 over 5. So when they ask for slope, you have to do the derivative of y over the derivative of x. Okay, now it says, where would the equation have horizontal tangent lines? So horizontal lines, that happens when our slope is 0. So look back right here at this fraction. We want to think about where it would equal 0. Well, a fraction is going to equal 0 when the top is equal to 0. So when y prime, which is 8t minus 1, equals 0, we're going to have a horizontal tangent line. So horizontal tangent lines, and I have this written down in just behind this screen, so you'll see it in a second. Horizontal tangent lines happen at the t values where y prime equals 0. Now vertical tangent lines are going to happen when our slope is undefined, and a fraction is undefined when its denominator is equal to 0. And its denominator is x prime. So we take x prime and set it equal to 0. That gives us the time at which a vertical tangent line would happen. So just to say that very clearly, horizontal tangents happen at t values that make y prime equal to 0, but not x prime. Vertical tangents happen at t values that make x prime equal to 0, but not y prime. Okay, the last thing is arc length, at least last thing for this video. Arc length of a parametric equation. Arc length for rectangular. So just to kind of remind you about the arc length we did with normal type equations. It was the formula S equals the integral from a to b of the square root of 1 plus f prime squared dx. So just for example, arc length of y equals x squared from x equals 0 to x equals 3 would look like this. Okay, that would tell us the length of the parabola x squared from x equals 0 to x equals 3. So if we were graphing it, hold on just a second. There we go. If we were graphing it, there's x squared, the parabola, we would be finding the length from 0 to 3. So now the formula for a parametric equation is similar. It's still an integral from a to b, it's still square root, and we're still squaring things, but we're squaring the derivatives this time. So we take the derivative of x, and we square that, plus the derivative of y, and then we square that. So here's an example. Find the arc length for x equals t cubed, y equals t minus 1, from t equals 1 to t equals 3. So we know we're going from 1 to 3. We know we have to do the square root of everything. So we do the derivative of x and square it, plus the derivative of y. Oops, sorry, the derivative would just be 1, and then square it. And we can simply plug that in our calculators. Remember, the AP test always show your setup for any. So if you're allowing to solve it in your calculator, you should still write that setup down. So we get math 9 square root of parentheses 3x squared, or it's t squared, excuse me, squared, plus 1 squared, close the parentheses for the square root, comma t, comma 1, comma 3. Just so you know, I am in parametric mode, that's why it's giving me t's whenever I hit that button. You do not have to be in any particular mode for this to work. You can be in regular mode or in parametric mode. The only time you really need to worry about your mode is when you're graphing or using your table. So we get 26.110 as our length. Okay, one more example. Find the arc length for x equals 5 cosine t minus cosine of 5t and y equals 5 sine t minus sine of 5t from t equals 0 to t equals pi over 2. Okay, well I just went ahead and wrote it down here for you. The arc length would be from 0 to pi over 2. Then you do the square root of everything. And then notice I've taken the derivative. Negative 5 sine t plus 5 sine of 5t is the derivative of x. It's x prime. And then I square that. Plus y prime, that's the derivative of y. Square that. You can plug it in your calculator and you should get 10. So there's more to come on the next video, so be on the lookout for that.